Okay, here's how I worked problems 3.7a and b. First, I'm going to go through the example problem. They're asking you in the first example, and 3.7a and b are just like the example problems, except they have different variables in them. So, and you have to draw this out. It doesn't ask you to do it with a math function. It asks you to do it by drawing and measuring. So you can either draw it by hand or you can draw in AutoCAD. You can also, it doesn't have to be so precise. We're not in that business here. We sometimes there's mistakes in the book, and I do think they got the first example wrong, and I'll show you why. But first, I drew it in AutoCAD because that's probably more precise, and I could draw it by hand. You have a wheel. It's 12 inches in diameter. I drew that. You have a force, this white line that is applied 9 inches above the horizontal surface. That line, I copied that line up 9 inches. You have this bump that's 3 inches tall. I drew that. Then I made my circle where it just touches that edge, and I'm sure you know how to figure that out. So with this force, they want to know what this force is that will cause cause the wheel to go over the bump. And the only thing you know is that there is a downward force, or that the wheel weighs 400 pounds. So I drew this downward line at 4 inches. You can see right there, 4 inches. So after I did that, I could draw my force polygon. And you can see that over here. I just basically copied that because this is the point of impact. So you have to have a line from there to where these other two forces meet. The gravity, of course, runs through the center, but that force is up there. So the point where all of these forces meet is going to be right here, 9 inches above the horizontal plane, which will be 3 inches above the center of the wheel. So you know that, and you know that. So you copy these forces over here to create your force polygon. And you know this is the only one that is a given, which is 4 inches or 400 pounds. I do 1 inch per 100 pounds. Then the other lines have to be parallel. So I copied this line. It was up here. I moved it down here to the bottom of my 4-inch line over to there. And then where those two intersect, this is the force. So that's how you figure that out. Now this is where it's different. It says the length here is 3 7/16 or 3.4641. The book says over 330 pounds is what your force has to be. Well, I think that's close enough. I think there's obviously a problem in the book, and the reason I think that is because I did the other problem and it worked out exactly. So, we shouldn't just get so hung up sometimes on the exact right number, especially when it's drawing things, because we're just looking for, in this particular problem, we're looking for just what force would it take. As an architect, we're not supposed to figure out the minute detail. The engineer is supposed to figure that out. We just need to have a good idea of what's making that force and how much it will take. So you can see on the second example over here, I drew the what did they call it? A masonry pier. That's this blue colored square. I drew my force that my white lines are force. It comes to here and it comes to the middle, and then that masonry pier, they say, weighs 10,000 pounds. So I already moved it over here, but originally I drew this white line right here was over here coming down from the middle because gravity acts from the middle. I drew that 10 inches long, 1 inch per 1,000 pounds. Then the other thing you need to have is the point of where it's going to tip. And in this case, they show you on the example that comes from down here. So there's a line, that's what this line was over here. I moved it from I drew a line from here up to the middle of that. Then I move those all the way over here to draw my force polygon. So again, the only given is this line here, which is the weight of the piling, which is 10 inches or 10,000 pounds. Those other lines are parallel to what they were over here. You can see that in the book. Then you draw where those two meet. This is the force it will take to tip that over, which is 2.5 or 2,500 pounds, and that is exactly what they come up with. So that is how you do those problems. It's not that difficult. It doesn't have to be a long mathematical equation. You just got to understand the principle. I've drawn the other ones down here, but I'm not going to go through that because I want you to go through it, but I will show you the answers because they're not in the back of the book. The first one, 3.7 right here, it says a cylinder with a diameter of 20 inches weighs 500 pounds. What horizontal force P will be required to start the cylinder over the block shown in figure 3.13a? That's on page 43. So the only difference here is you're going the other way from the example problem. So you just got to draw it out and figure it out. So a cylinder, the force P is going to be 400 pounds, I believe. Let me see. 20 inches. Yeah, 400 pounds. Then the second problem is a similar problem to the other one, except they're asking you they want to know if the horizontal force of 800 pounds will turn the pier over. And the answer is the force of 800 pounds will not turn it over. You will need a force of about 900 pounds. And I did that the same way. So I hope that helps you understand it. And if not, we'll go through it again Thursday in class. But I want you to try to draw this out and figure it out for me and then submit it for your assignment that is due today. That's all for this one. I'll go over the 3.9 in just a second on a different clip.